Hi everyone, welcome to my channel, Data Engineer Diary. In this channel, I'm going to share topics about data engineering and some practical hands-on tutorial. If you like my video, please subscribe to the channel and thank you very much. In today's video, I'm going to talk about distributed computing. So this is a technology that allows us to spread large-scale data across multiple servers by allowing vertical scaling and horizontal scaling to process large data in a relatively shorter time in compared to processing data in one single server. So this technology provides high performance and scalability, and because the distributed computing can handle large-scale data and complex tasks. And it also provides fault tolerance. If one node or one server fails, others will ensure the system stability and reliability. And also it allows resource sharing by efficiently using multiple computers resources. This technology allows us to cater the exponentially data growth in the industry. So next, let's talk about batch processing and streaming. So in in distributed computing, we have these two types of processing method. So the first one is batch processing. This method process data in batches, so periodically, could be daily, hourly, or weekly, and the data input is more or less static, and the processing delay is delayed because the data will be finished collected and only the batch processings will be executed. And it can the good thing is that it can handle more complex tasks, and the data processed are normally stored in a data warehouse or data lake. And and in terms of system complexity, batch processing is slightly higher or more complex in terms of for infrastructure, and error handling will be on the batch level uh, error handling, and the use case is mostly for historical analysis, etc. And when we talk about stream processing, we talk about a continuous stream of data coming in, and then the data input is more in a real time or near real time processing. And the complexity is smaller because it means the data needs to be processed fast, so it couldn't be a too complex task. And then the data storage could be a direct processing and then fit into applications, or it can also be stored in the data lake if needed. And then the system is relatively lightweight in compared to batch processing, and it has strong fault tolerance, and it can be done for like a real-time decision. When we talk about distributed computing, one of the first framework that we will think of is Hadoop. So it is an open source framework with two core components. So the first one is Hadoop distributed file system. So it's a distributed storage that divides data into blocks across multiple nodes in a cluster to enhance data reliability and accessibility, as you can see here uh, in the pictures. So, and then the second core component is MapReduce. So is used for parallel computing, suitable for batch processing tasks, especially handling large scale data processing. Okay, so let's have a quick look of the MapReduce concept. So it is a processing engine for parallel processing large data sets in cluster. So first thing, it breaks tasks into smaller units. Like here inside the input, it split data into different smaller units, and then it will divide using map. It will divide data into chunks and transform them into a key value pairs, like here. And then after a certain shuffling, and then by using reduce, it will organize, sort, and process key value pairs with the same key to produce a final result, which is a combined data set. Yep. So secondly, we will talk about Spark distributed computing framework. So it is a faster processing framework compared to Hadoop, which is using disk base, because Spark is using in-memory computation. So it also supports real-time processings. So it provides a unified interface for both streaming and batch processing. So Spark uses the Resilient Distributed Dataset, or RDD. It is an immutable dataset, meaning they cannot be modified once created. So new RDD will be created through transformation operation like map and filter, but the original RDD once created will remain unchanged. And also Spark uh, uses lazy evaluation, so it delays the execution operation as much as possible to reduce unnecessary intermediate uh, um, results generation and storage. So it will group a group of operation together to execute so that it can optimize the performance. So Spark is written in Scala, but it does provide API that support R and also Python. Okay, and Spark has multiple core component. The first one is Spark SQL, second Spark Streaming, Spark Machine Learning Library, and Spark GraphX. So before we move on to discuss about AWS Glue, which is AWS service that provide distributed computing. So we will talk about something the IaaS, PaaS, and SaaS, which is infrastructure as services, platform as services, and or software as services. It is just different cloud models that take away a certain certain level of responsibility from the user, and pass it to and let AWS or any cloud providers to manage it. So as you can see here from the left, if your server is on premises, you manage basically all this tier of all this level of your infrastructure. For example, you need to take care of networking, storage, servers, visualization, the OS, middleware, runtime data, and application. And when you move to the right, you will see for infrastructure, you will the first four layers will be taken care by the cloud providers, and then on the platform, you basically just need to worry about application and data. And then for the last one is for the SaaS, software as services. Basically, the cloud provider will take care about everything. You just need to use the software as it is. Yeah, and so AWS Glue is basically like the software as a services. So, what is AWS Glue? So it is a fully managed serverless ETL service. So ETL stands for extract, transform, load. So it simplifies and automate the data preparation and data integration. So it supports data like normal RDBM, MS, NoSQL database, and cloud storage. It provides automatic schema detection and metadata management. So it includes a data catalog for defining or store data structures from especially semi unstructured data or unstructured data. Yeah, as you can see here, it also provides an interface, quite user friendly interface, where you can just drag and drop the different components to form ETL job. But you can also do it in a code base. And under AWS, there's a sub component called Glue Crawler. So it is a powerful tool for automatic data discovery and metadata construction. So so you can imagine like bots that crawl through your data, whether it's a structured, semi-unstructured, a semi-structured or unstructured. So crawler will crawl through all this data, scan through all this data, and understand the structure of them, and then add all this metadata into another component called Glue Data Catalog. So it can serve as a centralized management and storage service for table metadata. Okay, so it provides so it can track the structures and also the location of data. So yeah, and what's the typical application scenarios of AWS Glue? As you can see here, so it can help to build the data lake and data warehouse because it allows to integrate multiple sources of data sets from various locations into a data warehouse to achieve comprehensive data analysis. Okay, and you can also provide real-time data processing like using Spark streaming ingestion. So it can provide instant business analysis and insights. And there's also another component called AWS Data Brew. It is more for people who are not too familiar with coding. So it has a no-code data preparation tools, something like a Microsoft Power Query. And it also provides features that can allow large-scale data migration between two data storage and format. As you can see here, the script ETL glue job can process data from S3 raw buckets, write it into a staging bucket where the data crawler will crawl through, save the metadata into the data catalog. Okay, and then it can process the data again into a new bucket. Yeah, and then yeah, using multiple glue job, you can either write data into Amazon Redshift data warehouse where other stakeholders can query the data. All right, so now I've finished just an introduction for distributed computing and AWS. So on the next video, I'm going to show you how to create an AWS Glue job and see how we can use it to process large data.